Hey folks, in this video we're going to be talking about combustion reactions and a little bit about thermochemistry. Fire, boom, let's go. So, a few objectives. I would like you to be able to identify and define combustion reactions. I would like you to be able to explain combustion reactions as redox reactions. We talked about those before. And I would like you to be able to at least define thermochemistry and define and provide examples of exothermic and endothermic reactions. And last one, I think, define heat. So, combustion. Combustion reactions are fire. Fire is a combustion reaction. Anytime you see something burning, combustion is taking place. And a combustion reaction usually, at least in our class, is going to take place between a hydrocarbon, something that's made of hydrogen and carbon, and oxygen gas. So a hydrocarbon is composed of hydrogen and carbon in different ratios, and oxygen gas is always O2. So other chemicals can combust, but we're going to keep it pretty simple. So combustion reactions generally produce H2O and CO2 as the products. If there's too little oxygen, you might produce carbon monoxide. This is actually what's going to happen in your home. If you have a heater that burns stuff and there's not enough oxygen getting to it, it can produce carbon monoxide, and that can be real bad. So burning other elements other than hydrocarbons can also produce other products. Like if you're burning sulfur, you can make sulfur oxides or nitrogen oxides. This is generally a thing people complain about with burning coal because it has lots of sulfur and nitrogen impurities, and those can go up into the air and react with water to form acids, and it's not very good. But anyway, our general formula, which we've seen before for a combustion reaction, is a hydrocarbon reacts with oxygen to produce CO2 and H2O, and I've left in blanks for coefficients because the coefficients are going to vary depending on what hydrocarbon is being burned. So more on combustion. Oxidation and reduction. Combustion reactions are oxidation and reduction, or redox reactions. In these combustion reactions, carbon becomes oxidized. The atoms are oxidized. They give away electrons, and they give them to the oxygen gas. As a result, the charge on carbon increases because it's giving away those negative charged electrons, and it's going to become bonded to oxygen after the reaction. Hence this name, oxidized. Oxygen gets in there and we form an oxide. The oxygen, on the other hand, is reduced because anytime something is oxidized, something must be reduced. And those oxygen atoms undergo reduction. They receive electrons from the carbon, and that causes them to form oxygen O2-. So the charge on each oxygen atom is reduced. They go from being neutral to having a -2 charge, hence reduction or reduced. And so here we can see that if we took just pure carbon and we burn that with pure oxygen, they both start out with neutral charges here. But the oxygen is going to get reduced. It receives electrons, and the carbon is oxidized. It gives away electrons to form a +4 charge. Nifty stuff. Here's a man who loves this giant crab. Look how jolly he is. Look how happy that crab is. Oh, they're just so in love. Anyway, basics of thermochemistry. If we're going to talk about fire, that relates to thermochemistry, or the study of heat. Thermochemistry studies how heat is exchanged during reactions. During most reactions, heat is either going to be absorbed or released. Released or absorbed from the surroundings of that reaction. So heat, I think, is something that's very interesting, and people mix this up with temperature a lot. They say something is hot, meaning it has a high temperature. But heat in chemistry is a form of energy, and it is different from temperature. It is thermal energy. When you give something heat, giving something heat will cause the temperature to increase. If you take heat away from something, that thermal energy, the temperature will decrease. Again, it is not to be confused with temperature. Only changes in heat are measured. We don't actually just go in and measure how much heat something has. Usually we measure the changes in heat, and we indirectly calculate how much heat something has. So when heat is released, the chemicals release heat to their surroundings. This is something that's described as exothermic. So if you're near a fire, you will notice that you get warmer. That's because you are absorbing that heat that the fire is releasing. This is called exothermic. Exo because it's on the outside. It's going outside of the reaction. Like bugs have exoskeletons, or exocytosis is stuff leaving a cell. Heat leaves when it is exothermic. And so these reactions or state changes are going to add heat to their surroundings. Like when you're near a fire, it adds heat to its surroundings. Or, for instance, very important one is the sun makes all these super cool fusion reactions that are very exothermic, and the sun, as a result, is very hot. So here's a visual representation of that. If we have an exothermic reaction, it's going to feel hotter than the surroundings. It's going to be releasing heat. On the other hand, we have reactions that absorb heat into them. These ones are going to absorb heat from the surroundings, and we call those endothermic. Endo meaning within. It takes that heat and it brings it within, like an endoskeleton, like we have, is inside of us, or endocytosis is stuff going into a cell. Endothermic is heat going into a reaction. And so, yeah, these are going to reactions where state changes are going to cool down their surroundings. Like if you have water boiling over a heat source, that water is actually absorbing the fire's heat. You put that fire there so the water will absorb it and boil. Or like when you're sweating, that sweat evaporating off of your body is supposed to pull heat out of your body. It is endothermic. It takes in the heat, that reaction. Cool. And so visual representation of an endothermic reaction would be this. It brings heat in, and an endothermic reaction is going to feel cooler than the surroundings. Another quick example is if you have an instant cold pack and you crack that thing, it gets cold. That's a very endothermic reaction occurring inside of that cooling pack. So using heat in reactions, we can show heat as a reactant or product. If we have an exothermic reaction that releases heat, well, a product of that reaction is heat. It gives away heat. If we have an endothermic reaction that absorbs heat, we're going to show heat as a reactant because it takes that heat in order for the reaction to occur. Anyway, that's the end of this video. I hope you understand a little bit more about combustion reactions and also a little bit about the basics of thermochemistry. I really hope that you know the difference between heat and temperature. Temperature, a measurement of how much jiggling is occurring in those molecules. Heat, a type of energy that can inspire jiggling or take it away. Anyway, ta-ta, have a great rest of your life.